Hello everyone. Today we are going to read lesson 3, The Changing Earth. For centuries, it was believed that the distribution and proportion of land and water on Earth's surface has always been the same and that the continents were fixed in their position. But the Earth did not always look the way it looks today. In other words, the United States 1 billion years ago was in a totally different location than it is today. How does this happen and why does this happen? Let's take a look. Continental drift. The Earth was formed 4.6 billion years ago and it has been changing ever since. One reason it changes is because of continental drift. Alfred Wegener was the meteorologist who proposed the continental drift theory in the early 20th century. His hypothesis proposed that the continents had once been joined and over time had drifted apart. Continental drift is the theory of how the continents move over the surface of Earth. He proposed that millions of years ago the land on Earth was all hooked together in one supercontinent called Pangaea. Greek word pan means all and Gaia means Earth. He said that over the years the land broke apart and became separate continents. This is called Wegener's theory of continental drift. Wegener's theory was improved upon by adding the concept of sea floor spreading. This new idea was called plate tectonics, formulated in 1960s. According to the theory, Earth has a rigid outer layer known as the lithosphere. The lithosphere is broken up into about 6 large plates and 20 small ones. These plates move constantly, typically at rates of a few millimeters per year, and interact along their boundaries. Such interactions are thought to be responsible for most of Earth's seismic and volcanic activities. When plates collide, mountains rise and volcanoes erupt. When plates scrape and slide past each other, an earthquake occurs. The different types of movements of the plates are due to various forces acting on it. These forces are divided into two main categories. The forces originating within the earth and causing horizontal and vertical movements are known as endogenic forces. Endogenic movements can cause slow or sudden movements and are responsible for creating major relief features such as mountains, plateaus, plains, valleys, etc. They are responsible for the movement of the plates. The sudden movements cause volcanic eruptions and earthquakes. The forces which originate on the surface of the earth are called exogenic forces. Weathering effects and erosion are examples of exogenic forces. Weathering is the breaking of rocks into tiny pieces, soil, sand, due to action of wind and water. Earth movements can be because of two types of forces, endogenic forces and exogenic forces. Endogenic forces are of two types, sudden forces and diastrophic forces. Sudden forces are earthquake, volcano, landslides, and diastrophic forces cause building mountains. Exogenic forces are erosional and depositional. It can be because of river, wind, sea waves, and glaciers. Volcanoes. Volcanoes are vents or openings in the Earth's crust through which molten materials such as lava, rock fragments, hot vapor, and gases are ejected. Sometimes this opening can be a long crack, which is called a fissure. The mountain or the volcanic cone is formed when the erupted materials accumulate around the vent, solidifying upon cooling. The vent is connected to the Earth's interior through a narrow pipe. The funnel-shaped hollow at the cone's apex is called a crater. Volcanoes are generally found where tectonic plates are pulled apart or come together. They are also found where there is stretching and thinning of Earth's crust, such as in the African Rift Valley. On the basis of the frequency of eruption, volcanoes are classified into three types. Active volcanoes. These are currently erupting or have erupted recently, such as Mount St. Helens Stromboli, which lies on an island near Italy, is a famous active volcano. Barren Island in the Andaman and Nicobar Islands is the only confirmed active volcano in South Asia. Active volcanoes are also called living volcanoes. Dormant volcanoes, also called sleeping volcanoes, these have not erupted recently but have the potential to do so again. Examples: Mount Kea of Hawaii and Vesuvius in Italy. Extinct volcano. Volcanologists do not think these will ever erupt again, such as Mount Buninyong in Australia and Kilimanjaro in Africa. These volcanoes have not erupted for hundreds of years and are also called dead volcanoes. Distribution of volcanoes. The Pacific coast of Asia, North America, and South America form a big circle which is called the Ring of Fire. The Pacific Ring of Fire is an area of frequent earthquakes and volcanic eruptions encircling the basin of the Pacific Ocean. This ring coincides with the edge of the lithospheric plates. It gets its name because it has the biggest concentration of volcanoes. The Ring of Fire has 452 volcanoes and is home to over 50% of the world's active and dormant volcanoes. 90% of the world's earthquakes and 81% of the world's largest earthquakes occur along the Ring of Fire. The Volcanic Eruption Index (VEI) is used to measure the magnitude of a volcanic eruption. The second belt of volcanoes is situated along the Mediterranean Sea and is called the Mid-World Mountain Belt. The volcanoes found here are mostly dormant or extinct. Mount Fujiyama in Japan is one of the world's most beautiful volcanic mountains. The Deccan Plateau of India was most probably formed due to a fissure eruption. Earthquakes. An earthquake is the shaking of the ground caused by the sudden release of energy in the Earth's crust. Earthquakes happen along faults or on the edges of different plates. Faults are breaks in a plate where pieces of rocks move. When one tectonic plate slides over or past another plate along the line of a fault, it causes an earthquake. In the ocean, an earthquake can cause a tsunami. Earthquakes are also called tumblers. The point inside the crust where the pressure is released is called the focus. The point on the Earth's surface vertically above the focus is called the epicenter. Earthquake energy is released in seismic waves. These waves spread out from the focus in concentric waves. The waves are felt most strongly at the epicenter, becoming less strong as they travel further away. Earthquake waves are classified into three groups on the basis of their mode of travel, namely primary waves, secondary waves, and surface waves. Primary waves or P waves or push waves travel the fastest and thus are the first to arrive. Traveling at an average speed of 6 km per second, these waves cause relatively smaller displacements, low tremors. Secondary waves or S waves or shake waves arrive the next, moving at lesser speeds than the P waves. These waves produce a strong shaking effect. These do not pass through liquids. Surface waves. The last to arrive travel over the Earth's surface. These waves are very powerful and cause most of the damage, though with depth their energy diminishes. These are of two types: love waves, lateral motions, and Rayleigh waves, wave-like motions. Seismology is the science that studies the cause, mechanics, and phenomenon of earthquakes, and the scientists who study it are called seismologists. The Richter scale is graded from 0 to 9, and an increase of 1 point on the scale signifies a 10-fold increase in the intensity of the earthquake. Earthquakes of intensity 6 or more are very destructive. On an average, about 10,000 earthquakes are recorded each year, most of which are slow and mild. Some are not even noticed. Severe earthquakes can cause landslides in hilly terrain, cracks in Earth's crust, bursting of river dams, and blocking of rivers, raising or lowering of sea floors or coastal regions. Measuring earthquake. An earthquake's power is measured on the Richter scale. Seismograph is an instrument that measures and records information about earthquakes. Distribution of earthquakes. Earthquakes have a definite distribution pattern. There are three major belts in the world which are frequented by earthquakes of varying intensities. These belts are as under. The Circum-Pacific Belt. This belt is located around the coast of the Pacific Ocean. In this belt, the earthquakes originate mostly beneath the ocean floor near the coast. This belt experiences about 66% of the total earthquakes that are recorded in the world. Most of the earthquakes occurring in this belt are shallow ones with their focus about 25 km deep and are of high to very high intensity. The Mid-Atlantic Ridge Belt. This belt is characterized by the sea floor spreading, which is the main cause of the occurrence of earthquakes in it. This earthquake belt runs along the mid-oceanic ridge and the other ridges in the Atlantic Ocean. In this belt, most of the earthquakes are of moderate to mild intensity. The mid-continental belt. This belt extends along the young-fold alpine mountain system of Europe, North Africa, through Asia Minor, Caucasus, Iran, Afghanistan, and Pakistan to the Himalayan mountain system. This belt experiences about 25% of the earthquakes in the world. The earthquake belt in India is mainly confined to the Himalayan region and Ganga-Brahmaputra valley. About 2/3 of India is earthquake prone. During the last 5 decades, the Deccan Plateau in India has experienced earthquake tremors, though this region is considered to be a non-seismic zone and safer. The latest version of seismic zoning map of India divides India into 4 seismic zones, zone 2, 3, 4 and 5. Earlier it consisted of 5 or 6 zones. Case study: April 2015 Nepal earthquake. The April 2015 Nepal earthquake, also known as the Gorkha earthquake, killed more than 8,800 people and injured more than 23,000. It occurred at 11:56 NST on 25 April with a magnitude of 7.8 on the Richter scale. Its epicenter was east of the district of Lambunj. Centuries-old buildings were destroyed at UNESCO World Heritage Sites in the Kathmandu Valley. Continued aftershocks occurred throughout Nepal within 15 to 20-minute intervals, with one shock reaching a magnitude of 6.7 on 26 April at 12:54:08 NST. The causes of this devastating earthquake were: Nepal sits on the convergence point of 2 tectonic plates beneath the Himalayas along a fault line. The Indian plate is moving north 45 mm per year and pushing under the Eurasian plate. The phenomenon in past resulted in the creation of the Himalayas. These plates are always slowly moving. Sometimes they get stuck at the edges. When the stress at the edges overcomes the friction, there is an earthquake that releases energy waves which travel through Earth's crust and cause the shaking. The Nepal earthquake had a depth of only 7 miles, which is considered shallow in geological terms. This was the reading of our lesson 3, The Changing Earth. If you have any doubt or query, you can ask me in the comment section below. Also, you can find the links to other lessons in the description box below. Thank you everyone.